you can make stationary waves out of like electromagnetic waves. You can make out of like in a string, in a string, or whatever, in a rope, or maybe in a bottle, like sound waves, right? So there are two different sectors. One is basically string, I think. Yeah, string. The other one is open 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 tubes. And the last one, like all right, so yeah, let's do one thing. Strings and tubes. See, I'm learning how to teach. Strings and tubes, right? So let's go with strings first. Oh, we are done with strings, right? And we will learn something called harmonic. This is very, very important for all of you. So what is a harmonic? What is a harmonic? Let's say you and your girlfriend is making, like, the initial condition I've made, right? You and your girlfriend on your first date, and now you guys have decided to go for some sort of fun experiment. Both of you are nerds, since you're in nerd community, like, you know, whatever, like, that's how life works out for you guys. So what is the first possible type of wave you can produce? So we have established that in a string, we have 2 points where the string doesn't really move, and that's the point we are calling node, right? This part and this part is node. So what is the first possible wave you can produce? One could be this, right? Yes, right? You can just move your hand upward, and your girlfriend does the same, and then the wave goes, reflects back. So how does it reflect? It reflects like this. Holy shit, so bad at this. It reflects back to point A. So this is a possible first possible wave, and these possibilities, like the ways you could make waves, like the wavelengths, the possible frequencies which make stationary waves, are called harmonics or resonance. So this is the first possible wave you can produce, and that's what we called first harmonic, right? That's what we call first harmonic, because this is the first possibility. So in this length, let's say this string has length L, right? So what is the length of the wavelength here? This is actually, if you like plot a graph, this is basically a 180-degree of the wave, right? So this is half of the wavelength. So L is basically half lambda, right? You guys got it, right? Yeah. So here, so wavelength is basically 2L. Now, what is the second possibility, second harmonic? This could be, since we're saying nodes are here, it's constant, right? This is how we can make the other one. I'm sorry, like I'm sorry for the bad drawing. I'm not really good at this. Just try to understand. It's another second harmonic. Let's erase the first one. Yeah, second harmonic. So this is the second possibility, right? Like, look at it. This is the first one. This is the second possibility, right? And if you notice, the string displaces here the most, like this position, so it's string of the strings of the string is where it displaces the most, and this is where the nodes are. But if you notice, there is also another node, like additional node added to the wave. This is also another node, right? And this is the second harmonic. This is the second possibility of making one complete wave. And what is it? Well, like, what is the wavelength? The wavelength here is basically L, right? One complete wave. Now your girlfriend and you, like, or your boyfriend, whatever, it doesn't matter. You guys have decided to, like, make another wave, the third harmonic, and it looks something like this, right? So this is where 360-degree ends, right? I've told you guys one complete wave is always 360-degree. So here, what's happening? How many waves are here? How many wavelength? Like, what is the wavelength here? So basically, one complete wave is formed at this position, and then we have another half of it. So basically, we have 1.5 waves here, right? Yeah, 1.5 is basically 3 by 2. So what is the wavelength here? The wavelength here is 2 by 3L, right? 2 by 3L. So if you notice the pattern here, if you notice the pattern here is basically, let's do this. Let's see a pattern. You know, one of the most fundamental human, like Homo sapiens features is we like to see patterns we like to find patterns in all sorts of mathematics, in all sorts of sectors in our lives. The first first harmonic was 2L. That's what we remember. Second had just L. Third one had 2 by 3L. So let's do one thing. Let's see a pattern. I can see what it's doing. There is a 1 here, right? There's actually 2 here, and this is divided by 2 because it's the second harmonic. And the same thing is happening here actually on the third harmonic. So we are actually multiplying the length with 2 and then dividing it with the number of harmonic it is. So do you see the pattern here? So we can safely say that the nth harmonic would be 2L divided by n, right? And I'm pretty certain you've seen this formula before, but somehow you've missed out, like you haven't actually understood how this formula came. It's actually our way of seeing how, like, sequence and series works. We came up with this formula just by noticing all the patterns. So if you go for fourth harmonic, fourth H, so what would it be? 2 by 4 into L, which is half L. Is it correct? Is half L correct? Let's see. If it's correct, then we can safely say our formula is correct. Half L. So your girlfriend or your boyfriend and you have decided to, like, have more fun, make another wave, another sort of the next level of harmonic. We have noticed that was 1.5. The last one we have learned was 1.5 waves produced in the L length of string, right? Now What is the fourth possibility? The fourth possibility is basically make this and this. Now, if you notice, there are two waves here, two complete waves in this position from point A to point B, and one wave is half of L, right? So holy shit, guys, this is correct. This formula works, and this is the formula you'll be needing. So the second formula, it's for harmonic. Harmonic for strings is, I don't think it's necessary to memorize the formula because I've never actually memorized it. I've seen patterns and then I've realized that's how it should be. We find the wavelength by basically this formula 2L by N, wavelength of any sort of waves, right? Like, or any sort of harmonic, and this is for strings.